Hello everyone, my name is Tuhin. This is episode 6 of the LangGraph series. Today we'll be building an intelligent ReAct agent. So let's see the agenda. So we'll be learning what is ReAct agent and we'll be learning about tools. This is a new concept and we'll be integrating tools with the agents, and finally we'll be building a ReAct agent. Then we'll run that particular agent to see how it works. So what is a ReAct agent? Let's not confuse the ReAct agent with the React.js. It is completely different concept and it is concept related to the agent. So ReAct is a combination of two phrases called reasoning plus acting, and it was introduced in a research paper by Google and Princeton University. And after reasoning, then it acts by calling tools, APIs or functions. Then it observes the results. While of reasoning is another paper that then it repeats from the first features. So it continues until the agent creates a satisfactory answer. Now it combines LLM reasoning with tool usage. Frameworks like LangChain and Google ADK, the agent development kit, implements ReAct agents out of the box. So let's see an example. So if user asks what's the weather in Paris, then how agent from the reactive agent perspective it works. Like agent thinks like I should call the weather API for Paris, then it passes Paris as an argument in the weather API, then it gets the answer like it's 18 degrees centigrade and clear skies. Now agent thinks that I got the answer, so I can go ahead and answer. So using the observation, then it answers like it's 18 degrees centigrade and clear in Paris. So this is how a ReAct agent works. Now we'll learn about tools. In LangChain, tools are functions or external capabilities that the agent can call when it needs to act beyond just generating context. A tool is usually a wrapper around API call. It can be a Python function like doing some complex logical operations. It can be a database query, can query to a file for the input output operations, or it can call another agent, or it can be a LangChain chains. So agent use tools in the ReAct, so reasoning and acting loop. So it first decides what to do, then it acts by calling a tool, then it observes the result and repeats until it is ready to answer. So for implementing tool, we'll be using LangChain library, and for LangChain there is an annotation available called tool. Let's consider we are adding a capability or adding a function called tool, and it takes two input parameters like a and b, and it adds them and produces another integer. Now for agents to understand that what the tool is intended to do, it is quite important to give a proper descriptions of that particular function or particular tool. So we will make it a practice that we have to add a descriptions for any functions or tools, a proper description and proper manner, so that the agent can route that particular request to a proper tool. And then finally it will when the agent receives the result, then it can act accordingly and observe the result, and it can loop through. So let's see how agent works with tools. And agent is basically an LLM that can decide when and how to call tools, follows the ReAct loops. So if a user asks something, what is the square root of the current temperature in Paris? So then agent thinks I need the current temperature in Paris, so it calls the weather API or weather tool. That weather API might be called inside the weather tool. Then agent acts, call the tool, call weather and passing the argument as Paris. Then it gets back the result 18 degrees centigrade. Then agent observes the result, then the temperature is 18 degree. Now I should compute a square root. Then it calls calculator and function square root of 18. Then it gets back like 424. Now agent answers the user the square root of today's temperature in Paris is 420. Now for creating an intelligent ReAct agent, we'll be using Python version 3.12.4. So if you want to follow along, then please install a Python 3.12.4. I have already created a video for creating multiple Python versions into the same systems, or creating a same Python version for a particular directory. So you can check that particular video in the link. And we'll need an OpenAI API key because we'll be calling the OpenAI for some LLM purposes. And required Python packages are LangGraph, Python.n, LangChain and LangChain OpenAI. LangGraph will be using for building graph-based agentic AI. Python.n will be using loading keys from .env file. LangChain will use to access core LangChain library functionalities, and LangChain OpenAI accessing OpenAI capabilities from LangChain. So finally we'll be building this kind of ReAct agent. So it will have a start node, it will have an agent node. Agent node will call the tool node based on the user query, and it will continue until it gets the final result. And once it reaches to the final end of the query, then it will end. Let's see it in demo. So we installed LangGraph, Python.n, LangChain and LangChain OpenAI using Poet Poetry. So command for installing different packages, you can run the Poetry at LangGraph. So before that I used Poetry init to create that particular project. For me, all the packages that I have already described, what are the purpose for using those particular packages, they're already installed, so I'll not be installing it again, but you can use this command to install. Now let's go to the project. So I have created a project called React AI Agent, and I've created a directory called source. Inside that src I will be creating some files for the different purposes. So let's start. First file we need to create is schema. So it's a schema.py, and we'll be creating a class called agent state. And if you have followed my earlier videos, agent state is a class which is used to hold or store the state of the agent across nodes. I'll describe the format of the particular messages. This is the property of that particular class, and it is annotated sequence of base messages and add messages. Now what does it mean? So sequence of base messages is like, you can consider it as a list of base messages, and base messages actually comes from LangChain core library, and the base message might contain the AI message, human message, or system message, or tool messages. So these four kind of messages can come inside the base messages. Okay? And add messages. So whenever a new message is getting appended in the list, we'll ensure not to create the entire list again. Instead, we'll just append the new message into the list. So we are done with the schema, and let's create another Python file. So we first here installed or called the all API keys that are used. So for API keys you need to create .env file, and here I have stored the OpenAI API key. Now we will be calling some tools called add, subtract, and multiply. I have not defined the tools yet, so I'll be creating the tools definitions in another Python file. We are using the ChatGPT 4o model for LLM related operations, and then we are creating two nodes called model call node and should continue. So model call node, what it does is like, we have given system messages that you are an AI assistant and answer my queries to the best of your knowledge, and then response, it will be using the system prompt, and state of the message, state is coming from the agent state. This is the state. So agent state we defined inside the schema.py. Then finally we are returning the response. And should continue, we already discussed about feedback loop, another video in the LangGraph series, so you can check that particular video. So it creates a feedback loop to check that until end is appears, it will continue. It will check that different tool calls. If there is no tool calls are being made, it will go to the end. If there is any tool calls, then it will continue. So based on that, it will continue that particular loop. Let's define the tools now. So we defined three tools. Like, so tool is, we need to annotate with the add tool. So it comes from the again LangChain code.tools, comes from LangChain library, and we defined three tools calling add, subtract, and multiply. So what it does, so addition is, it takes two parameters and just returns the sum of the two numbers. Subtract, it returns the subtraction of the two numbers, and multiply, it returns the multiplication of two numbers. But remember, it is important to give a descriptions of that particular function. Using that particular description, agent actually identifies that what that tool should do in a natural languages and calls that particular tool. So if we do not provide the description, the agent will not work correctly. So it is quite important for agents to work properly to provide the descriptions. Now we are done with the tools. Now you will create a graph. So for that, create a Python file called graph. Let's see what all things it contains. So first is like, we defined that particular graph using state graph and agent state we are passing as a parameter, and graph we are adding node. So first is the agent node and model call node functions that we defined already in the node section, that is the model call node, and we named it as agent node. And then we are creating another node called tool node, and this is the tool node, and the definition of tool node is we passed all the tools. So again, it comes from the LangGraph pre-built node that is called tool node, and we can pass all the tools inside. Okay, whatever the tools we have defined, and you can see all the tools we have defined in nodes here. So it contains a list of tools called add, subtract, and multiply. So after creating that tool node, we just added that node called tool node and named it as a tool node. Then we have created an entry point that it will start from the agent node, and we have added a conditional edges because previously we have created a function for creating a feedback loop, and it will, what it will do, it will start with the agent node, and based on that particular condition execution that is written inside the should continue. So if it is continue, it will go back to the tool node, and if it is end, then it will end the execution of that agent. Okay, and finally we created an edge between tool node and agent node. Next we'll be compiling the agent. So we are done creating the graph. Next we will be creating another Python file from where we'll be running the agent. So I have created an agent and in the graph.py, and now I'll be calling that particular agent to do some work. Now let's see what all things we are doing inside that main.py. So this is again printing that graph that we created in the ReAct agent. So we'll be seeing after execution that the visual graph will be generated inside output directory. Then we are saving that particular output file, that is the graph file, inside the output directory, and then finally we are calling the ReAct agent. So what we are doing, we are taking input from the user, and then we are passing the role as user, and we are passing the user input, and finally the print stream that we will be defining will create another particular Python file called utils, and inside utils create a small utility function. So what it will do, it will create a string that is what is the command that is coming from the user, and it will check that if it is a tuple, then it will go print, and it will just do some pretty print. Next we will go back to the main. Now the dependencies got resolved, so we are good to run that particular main file and run that agent. But before that, we'll simply create another directory called output where the visual graph will be stored. Fine. So let's run now. I'll ask that agent to add 11 and 20. So let's see what it does. So it calls a tool. It is calling a tool called add. So it is not being done entirely by the LLM. That's the important observation that we should see here. That is, it is calling the tool called add, and in passing the arguments called 11 and 23, then finally it is returning the result 33, and then it is telling the sum of 11 and 22 is 33. Now let's run it again, and I'll give another prompt that add 11 and 22 and 33. Now let's see. So our agent or our tool or the add tool actually takes two parameters. So how our agent does is like, that's how the reactive agent works. So first time it executes that addition of 11 and 22, so that is 33. Check, it is taking the natural language and passing that particular two parameters or two inputs in the function, that is 11 and 22, and it is generating the final, that is 33, generating the final value as 33, and then with the result it is again calling that add function. So that's how the feedback loop is working, and it is again calling with the result what it got generated. It generated, that is 11 and 22, it's 33, and it is finally adding them and generating them 66, generating the final result called 66, and this is the final results. The 11, 22 and 33 is 66. So it is calling the add tool twice, and it is looping until it is the node tool calls exist, and finally coming to the end node and exiting the agent. Now let's see another example. Add 2 and 3, then multiply. Now what is the expected result, and let's see whether it works or not. So now it's an important observation, that is 5 and 3. 5 we first added 2 and 3, that is 5, and finally it multiplied it with 5, then final result we received is 25, right? And it is correct one. So finally it's coming, the result of adding 2 and 3 and then multiplying the sum by 5 is 25. Now how it is happening? So first it's calling the addition tool, and then it's calling the multiply tool. So what are the results? First it's calling the add tool, that is add 2 and 3, add tool. You can see that add tool is being called, and then multiply is being called. Okay, so once the addition happens, the result of the addition it is taking, and then it is finally multiplying it with 5 and finally generating 25 as a result. So this is how tool call works. Now let's check the output of the ReAct agent that we created and how it is happening. So first it comes to the agent node, where it takes the input of the user query and it checks whether any tool nodes to be executed. It executes that tool. So for that multiple operations like add 2, 3 and 4 kind of situation. So first it adds 2 and 3, then it goes back here in the agent node, then it checks whether any other tool calls are needed or not, then it checks that okay, another add tool call is needed, then it again performs that particular action and goes back to the agent node. Now agent node identifies there is no tool call is needed, though it goes to the end and finally finishes the execution of that particular agent. So this is how the React agent works. So instead of this simple addition and subtraction operations, we can replace it with the API calls, and it will very well work in those situations. So this is the very fundamental concept, but this can be used to make very complex reactive agents. So in the next episodes, we will build a React agent with real world use case, and finally we'll use Langsmith or tracing. Stay tuned. If you have liked my video, then please like, share, comment and subscribe.